Hello, my online learners. I created a short video to summarize the special properties of water. So water is the topic of the day, and I am working off of the water and its properties worksheet. So we'll be looking at the reading in the textbook. We will also be looking at a couple of diagrams, and also I'm going to reference the water video, the YouTube video that's also in this module. So when we look at water, it's very important we look at the properties of water. And the unique properties of water are the fact that there are these electrons between the molecules and it shares electrons. So here is our oxygen molecule, which is larger. Here is our hydrogen molecule. They share with each other because it is it's too much work to lose or gain, so they share electrons. But they do not share electrons equally. Because the oxygen is a larger molecule, it will take and hold the electrons closer to it. And that means the electrons are more in the oxygen area. And since electrons are negative, it will make the oxygen end slightly negative. And because of that, there is now this drawn away from, the electrons are drawn away from the hydrogen, which makes that end slightly positive. It's just slightly. It's not strong enough to completely pull the electron away like a ionic molecule. It's covalent. So they're sharing electrons, but they're sharing it unevenly. When we look at the textbook, you'll see that there is a sort of a bubble diagram of the water molecule. Here's the oxygen. Here's the hydrogen. The oxygen is larger, so it is now slightly more negative, as a slightly negative charge. And the hydrogen, the hydrogen has a slightly positive charge. The little signs are wrong in your textbook, but just so you know. Slightly positive and slightly negative. And because of that, this is called a polar molecule. And it's this polarity in the water molecule that gives it this very unique property. And one of the unique properties is that the hydrogens of one molecule will interact with the oxygens of another molecule. And this is called a hydrogen bond. So here is your slightly positive end. Notice this little squashed music note. That means slightly. It's not a true positive or negative, but it's a slightly one. So this slightly positive end will be attracted to the slightly negative end. And that results in this lattice pattern as the water molecules interact with each other. And that gives the water its very unique properties. One of its unique properties is that it sticks together, or cohesion. So here they are, water molecules are sticking to other water molecules. Another one is adhesion, where the water molecules will stick to different substances. So let's pop back to our note page. On the note page, you'll see here we have our water molecule. It is polar because it has the slightly charged oxygen end and the slightly positive hydrogen end. Because it's got polar, it's got these slightly charged, which means you've got a positive pole and a negative pole. And it is polar because of the unequal sharing of electrons. And this is very important because if you have another polar substance, it will interact with this polar substance. But if you have something like oil, which is non-polar, it will not interact. And you may have seen this if you've ever got salad dressing, where the oil will float on top of the water. Now, some terms to talk about this like or not liking. So if you look at the term hydro means water, philic means liking, and phobic means scared. So if you are hydrophilic, you are a water-liking molecule, which could be something else, polar. So you're water-loving. Philic means loving. And phobic is water-hating. Now, when we look at that, that's just loving and hating. But the reason why it's water-hating is it's because it's a non-polar molecule. Now, non-polar means that the electrons are shared evenly. So there isn't this positive and negative charge. And a perfect example of a nonpolar molecule is oil. And we're also going to look at anything fatty. So lipids is the fancy word for fats. So we'll look at that. Then water-loving molecules are things that are polar, and as a result, they will dissolve. So things that are water-loving are other polar molecules. And that can include things like phosphates, anything charged, without getting into too much detail. So phosphates, which will be important when we talk about the membrane. So hydrophilic means it will like water, and hydrophobic means it does not like water. Okay, let's pop back to the video to look at the other properties of water. So here you have water with its slightly positive hydrogens and the slightly negative oxygen ends, and they will interact with each other. And when they interact with each other, this is when you get an intermolecular bond, which is in between molecules. And the oxygen end will be attracted to the hydrogen end, or the slightly positive is attracted to the slightly negative. And that results in a hydrogen bond. And hydrogen bonds will cause water molecules to stick together to form these special properties of water. One is surface tension, which, see how the oxygens of one are attracted to the hydrogen of another molecule. Oxygen attracted to a hydrogen of another molecule. That is due to different properties.
Stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion. Now, think back to the initial.
So two things. Cohesion, like cooperate, you're together. So water sticks to itself. Adhesion, it sticks to other things. So like thinking if you're adding more than one substance, more than one number. Now, because of these interactions, you will get surface tension. And surface tension is what gives the water the properties that insects can walk upon it if it's lightly. Then you also have hydrogen bonds, which is the interaction between molecules. And these hydrogen bonds we'll talk about it in a bit, but a hydrogen bond is a bond holding hydrogens to other oxygens, but it's held loosely. So in a DNA molecule, when they're zippered together, it's a hydrogen bond. Another thing about water is because of these hydrogen bondings, it will space out as it freezes, and ice will float on top of water. You probably don't realize it because you're not looking at a lot of frozen other substances, but in other substances, as things freeze, the molecules get closer together and they're denser. But because of the polarity of water, it spreads apart and it is less dense. I just want to emphasize hydrogen bonding because it is very important when we get into other molecules, other biological molecules. And that is the interaction of the hydrogen of one molecule to the oxygen, or we'll see later, nitrogen of another molecule. So due to the unequal sharing of the electrons, there will be an attraction to other molecules. And that's what hydrogen bonding is. Hydrogen bonding is very important in keeping the DNA molecule together, in coiling of proteins, and also other molecular interactions. And we'll get more detail into those as we approach them. So that is a summary of water.